Hello, I'm Fatin, and today me and my group we will talk about the dimethyl production of dimethyl ether from methanol. So I'm talking about now the objectives, and the objectives for the production of dimethyl ether from methanol are to develop dimethyl ether as a final product from methanol, and to obtain a final product purity of minimum 99.5%, taking into consideration the economic and environmental aspects. Also to obtain a production capacity of 50,000 tons per annum.
Hi everyone, my name is Ainun Syifa Salsabila, and I'm going to talk about the methodology of the production of dimethyl ether from methanol. There are 4 parts of the methodology. First one is identification of chemical component. Based on the research done, it can be concluded that the production of dimethyl ether from methanol is non-ideal system. The second one is selection of fluid package. Based on the data obtained from the simulation and other reference, Robinson Strajek-Vera, or known as PRSV, is selected as the fluid package. PRSV is suitable for component product of dimethyl ether. PRSV is modification of original Robinson method for moderate non-ideal system. It is more accurate than the PR method. In represent of better mixture and pure component, PRSV is selected. However, the calculation speed is slower than Robinson. The third one is setting up the reaction. To operate the process of production of dimethyl ether from methanol, the reactant is methanol and water, and then the product will be dimethyl ether. The fourth is process model development. To operate this process, temperature, pressure, molar flow, methanol and water mole flow composition inlet need to be assumed. Temperature is 25 Celsius. Pressure inlet is 100 kPa. Molar flow is 262.2 kgmol per hour. Mole flow composition of methanol is 259.70 kgmol per hour. And mole flow composition of water is 2.5 kgmol per hour. In this production of dimethyl ether from methanol, there are consists of 11 unit operation are used to achieve the production of dimethyl ether, include 2 pumps, 3 coolers, and 2 distillation column. The first is pump. Pump is a device to passage the liquid fluid by mechanical action, either reciprocating or rotary. There are 2 pumps operate in this process. The second one is mixer. Mixer is a mixing process by using manipulation operation to create a heterogeneous system into homogeneous system. The third one is cooler. The function of cooler is used to remove heat from the process. There are 3 cooler occur in this process. The fourth one is conversion reactor. Conversion reactor is used to convert the water and methanol into dimethyl ether by operation on a stoichiometric basis. The fifth one, distillation column. The function of distillation column is to separate mixture of 2 components into its component by heating to specified temperature, which one will evaporate and then condense. There are 2 distillation columns in this process. 6 is valve. Valve have a function to control the flow and pressure of liquid, gas, and slurry system. And then the last one is recycle. Recycle is a process to return back the product into its chemical monomer. In this process, the recycle occur after the pump, then recycle methanol and water to the mixer.
Hello, I'm Leena Jaiyashre. Today I'll be showing the process flow diagram that we constructed in Unisim design. We will start by adding the components which are water, methanol and dimethyl ether. Next, as for the fluid packages, we will be adding PRSV. Moving on to the reaction, we will be choosing the conversion reaction. As the base component is methanol, the reaction phase will be vapor phase and the conversion rate is 80%. As for the stoichiometric balance, the methanol will be -2, the water will be 1 and the dimethyl ether will be 1. Next, we have to do the reaction set, which is the global reaction set, and we need to activate the list, which is reaction 1. Okay, after that, we need to add the fluid packages here. Then we have to return to the simulation environment. Okay, this is the process flow diagram that we constructed in Unisim. Firstly, methanol and water at 25 degrees Celsius, 100 kilopascal and 100 kilogram mole per hour are fed to the pump. The molar flow rate of methanol is 99.3789 kilogram mole per hour and water is 0.6211 kilogram mole per hour. The effluent of pump has an increased pressure which is at 1550 kilopascal. Next, the methanol and water stream are sent to the mixer. This is to mix the components. In order to make the feed ready to enter the reactor, it must be heated since methanol is stored at 37.37 degrees Celsius. Next, the stream with water and methanol are then sent to the conversion reactor where the expected conversion is at 80%. As you can see, the effluent of conversion reactor have 0.383385 mole fraction of dimethyl ether. Before the components enter the distillation column, the stream need to pass through the condenser in order to decrease the temperature. In distillation column, the condenser pressure was set to 1030 kilopascal while the reboiler pressure was set to 1050 kilopascal. The effluent from top product is found to be dimethyl ether, which has 0.7999 mole fraction, while the bottom product is water and methanol. The water and methanol are sent into another distillation column and the methanol is recycled back to the mixer and the reaction goes on.
Hi, my name is Tahir. In this section, I will talk about production of dimethyl ether from methanol. Based on my friend said just now, the inlet properties of methanol was set to 100 kg mole per hour, while the temperature and pressure were set to 25 degrees C and 100 kPa. It is known that the composition of dimethyl ether obtained was 88%. After changing the molar flow rate of methanol to 262.2 kg per hour, while the temperature and pressure remains the same, it is known the compositions of dimethyl ether increased to 99.95 weight%.
So in conclusion, this report shows the dimethyl ether production process system, which includes methanol dehydration reaction system, heat transfer system, and separation system after the reaction. So the objectives mentioned in the introduction has been achieved, and the whole process for high purity dimethyl ether synthesis via methanol vapor phase dehydration was developed. And then the technological process was built on Unisim application, combined the parameters conditions for the reaction dynamic module for methanol dehydration reaction. On the inlet operating conditions of temperature is 25 Celsius and the pressure is 100 kPa and the flow rate is 262.2 kilomole per hour for methanol, and the reactor outlet conversion reached to 80%. The purity of dimethyl ether obtained was 0.995. And thank you for watching our video.